गुड इवनिंग बेटा। ये जे एडवांस का सेकंड पेपर है। लेट अस ट्राई टू सी हाउ फास्ट वी कैन डू द क्वेश्चंस। फर्स्ट क्वेश्चन देखिए बेटा, करंट इलेक्ट्रिसिटी से है। मैं जितना हो सका उतना करने की कोशिश कर रहा हूँ। आई डोंट नो वेदर माइंड का थोड़ा यूज ज्ञान हो और टेक्निकल एरर्स कुछ आ जाए। एनी हाउ, सी द फर्स्ट क्वेश्चन। ए मेटल वायर ऑफ क्रॉस सेक्शनल एरिया 0.5 mm स्क्वायर। एडवांस का सेकंड पेपर है। ओके। Area 0.5 mm square and length is 100 mm, 100 meters, is connected across a battery. Okay. Okay. A wire of cross-sectional area 0.5 meters square and length दे रखा है 100 meter, is connected across a battery of EMF 2 volt. Internal resistance is given as 1 ohm. The density, atomic mass and electrical conductivity of the metals are 6.35 into 10 power 3, 63.5 gram per mole, 2 into 10 power of 8 mho meter inverse. Assuming one conduction electron per atom of the metal, the drift velocity of the electron wire will be equal to how much? और उसने बोला है कि टेक द एवोगाड्रो नंबर है 6 into 10 power 3 and the charge on the electron is this much. चलो राइट द डाटा whatever he has given for me. देखो मैं यहीं पर कहीं करने की कोशिश करता हूँ। एरिया इज गिवन फॉर मी 0.5 mm square. That will be 0.5 into 10 power minus 6 meter square. Length will be equal to 100 meters. ठीक है ना? Area is given and length is also given and EMF is given for me. E value. E is equals to how much for me? 2 volt. Internal resistance is also given for me 1 ohm. Conductivity is given for me 2 into 10 to the power of 8 mho meter inverse. And you know that resistance of the wire is given by what value beta? Resistance of the wire is R is equals to, in terms of conductivity, if I'm writing, actually it is rho into L divided by A. In terms of conductivity, it is L divided by sigma into area. So length is given for me, so it is 100 divided by sigma is 2 into 10 to the power of 8 into this is 0.5 into 10 to the power of minus 6. So this will come out for me 1 ohm. Okay. Now tell me what is the total resistance of this one, beta? Total resistance of this wire will be equal to 1 plus of your 1. That will be equal to your 2 ohms. So current will be I is equals to V divided by R. EMF is given as 2. Resistance is also 2. So current will be equal to 1 ampere. Now you know that electron density formula, beta, isn't it? Electron density formula I'm writing here, you see. Write somewhere here. Yeah. Electron density. These are basic formulas which the student should always remember. N is equals to rho into Avogadro number divided by molecular mass. Rho value दे रखा है 6.35 into 10 to the power of 3 and divided by molecular mass, that is 63.5 into 10 to the power of minus 3. Avogadro number 6 into 10 to the power of 23. ठीक है ना? Easy calculation है. This will come up approximately 10 power 5. And this one is 6 into 10 to the power of 23. So this one is 6 into 10 to the power of 23. So this will be 6 into 10 to the power of 28 meter inverse cube. Now use the V-Naka relation. I is equals to VENA. Drift velocity होता है. I is equals to V now. So drift velocity will be equal to what? I divided by E into N into your A. करंट कितना है अभी अपने को 1 एम्पियर आया था डिवाइडेड बाय चार्ज ऑफ इलेक्ट्रॉन यू ऑलरेडी नो इट 1.6 into 10 to the power of minus 19 into n value I got 6 into 10 to the power of 28 above ऊपर आया था into area is 0.5 into 10 to the power of minus 6. So do this calculation. I'm using the calculator for this one better. So this one I'm getting 2.08 into 10 to the power of minus 4 meters per second. Yeah, this will be 0.208 mm per second. इतना कुछ आएगा आंसर। ठीक है ना? वो है क्या देखिए कहीं यहाँ पर It will be 0.28. Yeah, so C will be the answer. Clear? Sure. Next question is from nuclear physics. It is saying that a nuclear reactor starts producing a radioactive nuclide X at T is equal to 0 at a constant rate of alpha per second. Each decay of X produces E naught while it is utilized to heat a liquid of mass M and specific heat S. Assuming no heat loss from the liquid, taking lambda as a decay constant of X, the rate of increase in the temperature of the liquid will be equal to how much? Sure. This is something like related to your heating produced due to the radioactive production. Okay. So for this one, if I'm using the relation C, radioactive correlations, this is your question number 2. Write with another pen. Okay, fine. So number of nuclei produced per second will be equal to how much, beta? Number of nuclei, number of your nuclei which are produced per second. Per second is given how much for me? Alpha. Is given for me as of your alpha. So let n, capital N at a time t be the number at a time t seconds. At a time t seconds. That means you know the formula dn divided by your dt is equals to your alpha minus lambda into your n. And you know that solution of this one will be n is equals to alpha divided by lambda into 1 minus exponential to the power of minus lambda into t. And decay rate, you already know it. Decay rate का formula क्या होता है? Lambda into your n is equals to alpha into 1 minus exponential to the power of lambda into your t. Now power generated will be equal to your how much for the given condition? क्या होगा बताइए power generation? Power generated P is equals to your, this is your E naught alpha into 1 minus exponential to the power of minus lambda into T. Okay. And you already know that power is also equal to ms into your dt divided by dt, isn't it? So that is equal to right now for me your E naught into alpha into 1 minus exponential to the power of minus lambda into T. So now I can write here dt divided by dt is equals to your E naught into your alpha divided by m into your s into 1 minus exponential to the power of minus lambda into t. So this should be the answer for this. Okay. So rate of increase of temperature of the liquid is asking. So what might be my answer? 1 minus exponential to the power of minus lambda into t. So first option, which I'm feeling comfortable. Okay, I hope you can check it out. But see, I'm doing an online. Maybe some problem हो गया तो बाद में अगर कोई की mistake है तो I'm extremely sorry. But to my extent, I'm trying to do my best to give the solution as early as possible. चलो, question number third one देखो बेटा. Question number third one. The question says that a beam of polychromatic light passes through a thin prism of prism angle 6 degrees. The refractive index of material of the prism varies with wavelength lambda as alpha is also given as 3 micrometer inverse and beta is given as 0.096 micrometer square. If lambda minimizes the wavelength at which the angle of minimum deviation is being smallest, then the correct value of the dm will be at lambda minima is how much? This is something related to your ray optics in the prism concept beta. पर तीन प्रिज्म्स आपको ऑलरेडी मालूम है for thin prisms you already know the relations. Minimum deviation will be equal to refractive index nu minus 1 into your angle of your prism. Now, given in the problem is, see here refractive index is represented by letter n beta. Okay, so here also I'm using mu is equals to n. So for your confusion, I'll repeat this one. So it is n minus 1 into your a. Because in the problem he is using the refractive index of the material as of your mu beta. N is n se represented. Generally, while teaching, I take as mu. Anyhow, now given is right now for me. Refractive index for a given wavelength lambda is equals to alpha into lambda plus beta divided by lambda, isn't it? So, okay, that is given value. So, minimum deviation I can write here as d minimum is equals to your, this will be equal to your A into your alpha into lambda plus beta divided by lambda square minus 1. So, minimum deviation condition is what beta? Deviation, minimum deviation condition. Minimum deviation condition is d differentiation of this one with respect to your d lambda must be equal to 0. That means it will come out for me alpha minus 2 beta divided by lambda cube is equals to 0. That means lambda cube is equals to 2 beta divided by alpha. So that is equals to 2. Beta value is already given in the problem as 0.096. यहाँ पर दे रखा है देखो. This is given for me. Divided by alpha value. What is the value of your alpha Q? I got it right now. Alpha value, I got it. I'll be getting as of your, what is given alpha value in the problem? Oh yeah, alpha value is given as of your 3. So that is given as right now for me in the problem 3. So this is a 2 by 3 into 0.096, approximately 0.064. This will be the answer for 0.064. Okay. And I got this one as of your lambda cube value, no? So lambda कितना हो जाएगा बताओ इसमें से? This is lambda cube value. To know this one. This is lambda cube. So lambda value will be approximately 0.4 micrometers. Clear till here? Now, what is the refractive index is asked. So n is equals to, this is 3 into 0.4. This is given already value. So I'm using this one, right? Plus beta. Beta value is how much for me? 0.096 divided by 0.4 whole square. I'm hoping that your calculations are very strong beta. Otherwise, it is really difficult to do these calculations. So it is 1.2 plus of your, it will be 0.6. It is approximately 1.8. तो मिनिमम डिविएशन का जो फॉर्मूला राइट नाउ था मेरे पास मिनिमम डिविएशन को फॉर्मूला ये वाला यूज कर लो सो मिनिमम डिविएशन विल कम आउट फॉर मी डी मिनिमा इज इक्वल्स टू refractive index is 1.8 what I got it is minus 1 into 6 degrees कर लो so that will come out for me 0.8 into 6 degree so it will be 4.8 degree this will be the answer for so best option is third okay. Sure. Question number 4 then. Yeah. A particle of mass m and angular momentum L is moving in a circular orbit of radius r naught under the influence of an attractive force Fr is equals to minus k by r square r cap. Keeping its angular momentum unchanged, the particle is displaced radially by a small distance. dr is much lesser than r naught, due to which the radial distance varies periodically. The corresponding time period will be equal to your how much for me? A particle of mass and angular momentum is given beta. See here, this is related to your small radial oscillations concept beta, where potential energy is being given as a function of your F particulation. Now, effective potential energy will be equal to how much for me? When force is being given, you know the formula F is equal to minus of du divided by your dr. Okay, so I'm writing this effective potential energy. U effective will be equal to L square divided by your, this is right now for me, 2m into your R square minus K divided by R. Okay. So now for your circular orbit, you know that du by dr must be equal to 0. That means minus L square divided by m into your R cube minus of minus it will become plus. It is K divided by your R square. That must be equal to how much for me? 0. That means from this one, I will be getting the value of your R is equals to L square divided by M into your K. Isn't it? Now, oscillation frequency, you already know it. Oscillation frequency. Oscillation frequency. Omega square is equals to 1 by M into d square u divided by your dr square. Limit will be equal to your R naught or R you can take basically. Okay. So d square u divided by your dr square will be equal to, this value will become for me 3L square divided by m R power 4 minus 2K divided by R cube. Now substitute the value of your R beta. Substitute the value of your R. So you'll be getting omega square is equals to m square K power 4 divided by L power of your 6. If I still simplify this one, the time period T is equals to 2 pi divided by omega. That will be equal to 2 pi. Omega value will be equal to square. If I'm removing it, we'll be getting the value of omega from this one. I can write as m into K square divided by L power 3. So this will be equal to omega. It is your m into your K square. This is L power 3. That will be the time period. So it is 2 pi L cube divided by m into K square. A value will be the answer for it. Okay. चलो सेक्शन नंबर 2 में है 20 मार्क्स का वेटेज. Full marks is +4, partial marks is +3, and for all options would only 2 or correct. Only of negative marking -1 है. चलो, let us try to see this type of questions. Oh, my goodness. Complete diagram देखे तो ही डर हो रहा है basically, isn't it? Let's see. The problem says me right now here. Consider two isosceles prisms 1 and 2 with the prism angles A1 and A2 and refractive index N1 and N2 respectively. As shown in the figure, the faces A1, B1. Where is A1, B1? A1, B1. This is the face of your A1, B1 and A2, B2. This is your A2, B2 are parallel to each other and perpendicular to the mirror M. This is your mirror M. Very good. If a ray of light is incident on the face A1, C1, where is A1, C1? Yeah, this is a ray of light which has been incident on the surface and emerges from the face A2, C2. It is right now for me here A2, C2. Then correct statements are, Baapre, my goodness. Ray of light is incident, emergence is also there. And he's telling that A1, B1 are parallel. That means it will become for me minimum. So I can use your minimum deviation relation beta. Sorry, I'll write with a black pen. Yeah. In minimum deviation, in minimum deviation, because rays are parallel, na? So refractive is here is represented by n. N is equals to sine A plus of your D divided by 2 divided by sine of your A by 2. ये तो formula आप लोग को clearly मालूम है. Now for symmetric geometry here right now for me. For your symmetric geometry. Okay. देखो I1 will be equal to how much for me? I1 will be from the diagram, it is very clear. I1 will be equal to your angle of your prism. I1 हो गया यहाँ पर emergence. So this will be equal to your A2. So I1 will be equal to your A2 plus of your minimum deviation due to the second one divided by 2. Okay, now if I'm applying the Snell's law at the first surface, So sine of your I1, because you're going from the air, no? So it is 1 into your sine of your I1 is equals to your, this is N2 into sine of your A2 divided by 2. So for prism 2, if I talk about I1 will be equal to N2 into sine A2 divided by 2, sine I1. So second option मेरे correct दिख रहा है. ठीक है ना? So B is true for this one. Both the prisms are minimum deviation. N2 by N1 will be equal to your how much for me? Okay. Let us me check with the first one also here right now. For the second phase, if I'm talking about sine of your I2 must be equal to your N1 into your sine of your A1 divided by 2 for the first surface. Isn't it? So for the first surface, this one is the relation. So sine of your I2. So D also I'm getting the answer for the prism 1. This is for prism 1. This is for prism 2. ठीक है ना? That. For thin prisms, minimum deviation will be equal to your n minus 1 into your A. So from this one, I can write here theta will be equal to A1 plus A2 divided by 2, isn't it? So if I'm writing this one relation, theta value, this is the deviation of the first one divided by 2 into n1 minus 1 plus of your deviation of the second prism divided by 2 into n2 minus of 1. So obviously C is also correct for this. Okay. So only thing is incorrect is the first option because I already did here right now for that. Okay. Na? Sure. No problem. Question number 6. Therefore. Question number 6. In a vacuum chamber, a particle of charge 1 microcoulomb and mass 1 milligram is projected with a velocity of I plus 2 j cap meter per second from xz plane at a time t is equal to 0 in an electric field of 1 I voltmeter inverse. T is equal to 0.2 seconds. The electric field is switched off and magnetic field 6 j cap Tesla is being switched on. The acceleration due to gravity is minus 10 j meter. Choose the correct options. The vertical distance of the particle from xy plane, the vertical distance of the particle from xz plane, the radius of the trajectory, the particle will be in xz plane. Okay. We need to check with all the options on this one. So I'm writing here sixth one. See here. Now see, this is like some charge particle moving in a field. So for the given time, how much for mu? 0 lesser than of your t and t lesser than of your 0.2. Now see, for electric oscillations, we know acceleration along x-axis is equals to QE divided by M. That is equals to your, this is 10 power minus 6 divided by 10 power minus 6. That is given in the problem. It is 1 meter per second square, which I'm getting. Now due to gravity, we know that acceleration in the vertical will be equal to minus 10 meter per second square. So what is this initial velocity? U bar is equals to your 1 into your I cap plus of your 2 into your j cap. Okay. Then at t is equals to 0.2 seconds is asking. T is equals to 0.2 seconds. Velocity along x-axis will be 1 plus 0.2. That will be equal to 1 point. And vertical velocity along y-axis, Vy will be equal to 2 minus 2. That will be equal to 0. So therefore, height will be equal to how much? H is equals to your u into t. That is 2 into 0.2. G is negative, so it minus half into this one is right now for me 10 into 0.2 whole square time. So that will be approximately 0.2 meter is your height reached by this particle. In which direction? Y direction you can see. Y is equals to H. Okay. So after this, the magnetic field will be acting since V bar is parallel, he's telling in the problem. How about the electric field is switched off and magnetic field of 6 J cap is switched on. The acceleration due to this gravity will be equal to how much? Now see, in this case, after magnetic field, that means after 0.2 meters, the magnetic field will be start. Since magnetic field is telling parallel to your J cap, so magnetic force changes only xz motion, isn't it? because it is moving in y direction. So vertical motion is affected only by gravity. Vertical motion is affected by gravity. Okay. So that means at a t is equals to 0.3 seconds. Y will be equal to 0.2 minus half into this is your 10 and 10 0.1 whole square. That is 0.15 meters approx. So that means the vertical displacement distance traveled with the particle in z at t is equals to 0.3 will be 0.1 meter I got. Okay, so 0.1 meter means the problem is given 15 centimeters. So this will be equal to 15 centimeters. So first option, which I feel is correct right now. Okay, then again, at t is equals to 0.4 seconds. Second option to try to see it out. Next one. At t is equals to 0.4. Y value will be equal to 0.2 minus this is half into 10 into this is 0.4 minus 2. That means 0.2 whole square. That means it will become for me 0. Okay. So if it is becoming 0, it is given 10 centimeters. So B will not come out with us. So this is not coming out for me. The next one is the radius of trajectory of the particle is asking. Radius of the trajectory means we already know the formula, very famous. R is equals to mv perpendicular divided by B into Q. Mass is 10 to the power of minus 6 into this is 1.2 divided by charge is right now for me or given condition 6 into 10 to the power of minus 6 hoga, and the value of your Q will be equal to 10 power minus 6. So given conditions, if I'm using the relation, T is equals to gravity field, charge is 1 microcoulomb, that is 10 power minus 6. So charge is equals to 10 to the power of minus 6 into magnetic field. Magnetic field is equals to your 6. So if I simplify this one, 0 point, this will get cancelled, this will get cancelled, 1.2 divided by 6, it is 0.2 meters. So I'm getting this one as 0.2 meters. That means 20 centimeters. So C is true. Okay. Now see, next one is telling is a particle will be in XZ plane at t is equals to 0.3 seconds. Okay. Let me see. Particle see here right now for me because radius is 0.2 meter. So the particle returns to plane at t is equals to 0.4, but not at 0.35. So 0.35 is not possible. So only A and C are correct for this. Clear? Sure. Paper, yeah. I'll do up to the question number 9. Let's stop for this. Question number 7. Two particles Q1 is equals to Q, Q2 is equals to MQ are placed at points P1, P2 respectively in the XY plane where AB is not equal to 0, M0 is not equal to 0, and 0 and 1. If V1 is the potential at a point in XY plane due to the charge Q1, V2 is the potential at a point due to Q2. Correct options for this one will be equal to how much? Two charged particles, Q1 is equals to Q and Q2 is equals to MQ, are placed at the points P1, A comma B, and P2, MA comma MB respectively. Okay. In the XY plane, where A, B are not equal to 0 and M is also not equal to 0 and 1. If V1 is the potential at a point P in the XY plane due to the charge Q1, V2 is the potential at a point due to the charge Q2. What is the correct relation is asking. Okay. Try to do here itself, we see. So equal magnitudes, equal magnitude in your potentials. That means I can write here, potential will be Q1. What is the given condition right now for me here is mod of Q divided by R1 will be equal to M into Q divided by your R2. That means R2 value will be equal to mod of your M into your R1. Okay. I'm using the mathematics little bit here right now. This is a condition. Now, let me check with your options. If I keep M is equals to -1, it will be what? Perpendicular bisector. That means AX plus BY will be equal to 0. Okay, so A is correct. I'm using the mathematics. In the same way, if I keep M is equals to 2, so circle is center and radius should match for this. So radius will be equal to, and radius is also matching. M is equals to 2 if I'm keeping the relation. The locus of the points will be equal to. You can just check with your options better. And even check with your M is equals to your -2 now. Now its center should be 4A divided by 3, comma 4B divided by 3. So it is not 2A, 2B. So here I'm not getting this one. So I got the value of your A. I got the value of your B also is matching. M is equals to -2 is not matching. Okay. Now if I take M is equals to -3, isn't it? It's not a linear locus. Okay. No? So it is not possible. So I feel that D is also wrong. So only A and B will be correct for us. Okay. Sure. Next question. Consider an electric dipole comprising two equal charges, plus Q and minus Q. Electric dipole होगा बेटा. With a mass m separated by a fixed distance d and initially at rest with a dipole moment pointing I cap. Uniform electric field is being turned at a time t is 0 and is turned off at t is equal to t. When dipole moment makes an angle t final with initial I cap, neglecting any source of energy loss, correct options are: the center of mass of the dipole is deflected j cap in the presence of field. If the magnitude of the final angular velocity is given, we need to check the theta, change in kinetic energy, and theta with angular velocity. Okay, let us try to check with this one. So what is the torque acting on a dipole beta? I hope you have may have been remember this one. So torque acting on a dipole is T tau is equals to PE into your sine theta. So there is no net force acting on this one. So net force is equals to 0. That means center of mass does not move. If center of mass does not move, that means the center of mass of the dipole is deflected towards a j cap in the presence of the field is telling. No, it will be your false. It is not correct. Okay? Because there is no net force. The center of mass does not change at all. Okay? So the next one is moment of inertia. If I'm talking about I is equals to, this is right now for me 2m into your d by 2 whole square. So it is your m into your d square divided by 2. Now applying the energy conservation, that is half into I into omega final square must be equal to your PE into your 1 minus of cos theta final. So it is your half into moment of inertia of this one is m into d square divided by 2 into omega final will be equal to your how much right now? 2QE divided by m into d. That is equals to your Q हो गया right now for me. M is right now for me. This is your dipole. P is equals to Q into E into D into 1 minus of your cos theta final. So if I simplify this one, So this will be coming out for me 4, this 2 and this 2 will get cancelled here. So this will be equal to QED divided by 2. That is equals to QED into 1 minus of your cos theta final. So QED will get cancelled. So cos theta final is coming out for me 1 by 2. That means theta final must be equal to pi by 3. So magnitude of angular velocity, omega final is given this much. For this angle, this is not possible. See what, how much I'm getting? Theta pi. See here, omega final, what you have written is, this value is from this one. Don't get confused. Where do I got from this one? Because in the problem already has given. That is the reason I substituted that value there. Okay, now. So second one is also false. That means B option is also false. Now, third option, what he has given is, if theta final is equals to, he has given me pi by 3, the change in kinetic energy of the dipole is how much is asking. Okay. Now, if I take theta value for theta final is equals to pi by 3, kinetic energy will be equal to how much? Change in kinetic energy will be equal to QE into D into 1 minus cos of your 60 degrees. So that is equals to QED divided by 2. So how much I'm getting here? 2ED. So this is also false, what I feel. So third option is also false. Now see, after this one, what is the fourth option is telling? If theta final is pi by 4, dipole rotates around its center of mass with a constant angular velocity after t greater than t final. Okay. T final, what is given in the problem? It turned off at t is equals to t final. Okay. So that means after field is removed. Now tell me, after field is removed. After the field is removed, there is no torque at all. So there is no torque means it will remain for your constant. That means it is your constant angular velocity. It is a constant angular velocity. Dipole rotates with a constant. So C, D is the correct option. Okay. Sure. Question number 9. Okay. 10 moles of 10 moles of an ideal monatomic gas initially at state A at atmospheric pressure and temperature 27 degrees Celsius is enclosed in a metal cylinder of volume V0 fitted with a frictionless piston. The gas is suddenly compressed to the state B with volume V0 by 3. Now, keeping the piston stationary, the cylinder is submerged in a water bath by 11 degrees Celsius until the gas reaches the temperature of water bath, which is denoted as state C. Finally, while the state in the water bath, the piston is brought slowly to the final position, which is denoted as state final. Or is gas constant? Then correct. Okay. So this is your A, this is your B, this is your C, this is your F. Okay. Pressure and volume condition. The change in internal energy is asking the change in internal energy for the whole process, the A, and the systematic PV graph of the process is also is asking right now. Okay, chalo. So see the question number 9 now. Okay. So what is the given temperature beta for me? 27 degrees Celsius. So in Kelvin, it will be equal to how much beta? Temperature of your A will be equal to your 27 plus 273. It is 300 Kelvin. So sudden compression means it is an adiabatic process. It is TV to the power of gamma minus 1 must be equal to your constant. Okay. So it is right now for me temperature at a point of your B. So temperature at your B will be equal to 300 into 3 to the power of 2 by 3. So that is coming out for me 300 into this is 2.08. That is approximately 624 Kelvin. Okay. So the pressure and temperature of state B are 2.08 times of the atmospheric pressure. So it is 624 I'm getting. So D is correct for. Okay, na? That already given in the option. That is the reason I'm reading the options first. Okay. The next one. Pressure if I'm taking it to a point B. Next one. Pressure at a point B is equals to your pressure at your EA 3 to the power of gamma. That is equals to pressure at your EA 3 to the power of this is 5 by 3. Okay. प्रेशर कितना बोल रहा हूँ वहां पर? प्रेशर at B is 2.08. So partially I'm not getting this one. Pressure at your B is equals to 3 to the power of 5 by 3. It is not coming to be 2.8. So D is partially wrong because pressure statement is incorrect here right now for me. So what I can write here for this one, then D will not be correct. So only I'm getting one option here in this one. So DP is not equal to 2.08. So D is partially wrong, beta. Okay, let me check with your internal energy. Internal energy will be equal to, from A to B will be equal to 3 by 2 times of NR into, this is 624 which I got, minus 300. So this will be equal to 15 into R into 324 divided by 2. That is 2430 R I'm getting. So the net change in internal energy for the whole process is 2430 I got. That means it is also not correct. Okay. The next one. Final state temperature, how much I got with it? 284, no? So final temperature is 284 Kelvin. So net energy will be equal to how much? 3 by 2 into this one is your 10 into your R. This is 284 minus 300. So this will be equal to 2 ones. This is 2 fives. 3 fives is 15. 15 into R 284. So this will be 240 into your R minus. So 240 into your R. D is wrong, no? Sorry. So the next change in internal energy means it is 48. This will be wrong, beta. C will be correct. C will be correct. B will be wrong and D is also partially wrong. Okay. Now question number section 3 is right now for me what? So section 1 we have done. Section number 2 we have done. Section number 3. Okay. Numerical questions. 5 questions, numerical value +4 and 0 marks. Okay, chalo, let us see the first question. Two thin wires, wire 1 of diameter 0.65 mm, wire 2 of unknown diameter D are given. The obtained value of D, the diameter of the two wires are measured with the screw gauge. The screw gauge has a pitch of 0.5 mm and there are 100 divisions on circular scale. The smallest division on the linear scale, the table shows the reading measurement. The value of D is how much? This is my favorite question from the screw gauge right now. So let me give the data what he has given for me. Given data is diameter of the wire is given as of your 0.650. Okay, this one is right now for me mm. And pitch is given for me, 0.5 mm. And circular scale divisions are given for me how much? 100. So least count is right now for me 0.5 divided by 100. So that is 0.005 mm. That is coming out for me 5 micrometers. Now see, using the readings from the table, not visible clearly, the measured diameter difference must come out for me approximately, diameter difference will be approximately some around 0.95 diameter, whatever you have taken right now, this difference between them. The table shows the smallest division of linear scale is 0.5 is telling. The value of the D in micrometer is asking. So the value of the D will be coming out for me 0.795 mm. That means it will be 795 micro mm must be the answer. Okay. So I think that must be the answer for that question. Chalo. Question number 11, you see below. In a single slit diffraction experiment, a slit width of 0.016 plus or minus 0.002 mm are being used to measure the wavelength of monochromatic light source. The diffraction pattern, the angular distance between the central maxima, first minima are measured to be 2 degree plus or minus 40 seconds. So, okay, the value of the fractional error in the measurement of the wavelength is given sine 2 degrees 0.03. This is also a good question, better. See, whatever is given for me, this is fractional error in the wavelength. For single slit diffraction, you know the formula? For single slit diffraction. For single slit, your diffraction, A into your sine theta is equals to lambda. Hence, if I take in terms of error, delta lambda divided by lambda is equals to delta A divided by A plus this is delta into your sine theta divided by your sine theta. Okay. Given for me, given A is equals to 0.016 plus or minus 0.002 mm. That is given. So if I write the error for this, delta A by A will be equal to, this is 0.016. It will be delta A by A will be equal to 0.002 divided by 0.016. This is approximately 0.125. Okay. Angle will be equal to how much? Angle is right now for me, theta is equals to 2 degree plus or minus of 40 inch. Now, if I take convert this one 40 degree divided by your 60. So that will be equal to 2 by 3 degree, isn't it? That means for small errors, for your small error, delta sine theta divided by sine theta, I can approximate it to delta theta divided by tan theta. So using your radians into consideration, delta theta will be equal to 2 by 3 into pi by 180. So this will be 0.0116 approximately. Okay. Now given in the problem for me, given 2 degree is equals to 0.035. So I can write here delta t into sine theta divided by your sine theta is equals to 0.0116 divided by 0.035. This is approximately 0.331. So now total fractional error will come out how much for me, beta? Total fractional error will be 0.125 plus 0.331. So that is approximately 0.456. So this must be your answer. That means if I write in the booklet, it should be 0.46 must be the answer. Significant figures, rounding off कर रहा हूँ तो basically. ठीक है ना? Okay. Section 4 is also there in this again. Okay. Okay. See the question number 12, beta. As shown in the figure, a ray AB of unpolarized light enters the water of refractive index 4 by 3 into medium of refractive index 4 by root 3. After passing through a glass plate of refractive index 1.5, a layer of water at a particular incident reflected rays polarized in a direction as shown in the figure. The value of I will be equal to how much? This question is from polarization, beta. Wave optics का question है. If I take this relation from the given diagram, ray of light is being incident. ray of light is been incident from here. Then from here, this reflecting 1.5, then reflectance of water 4 by 3, then 4 by root 3. First medium and last medium are right now water, and it is your NP. Okay, apply the Snell's law, beta. Reflected ray to be polarized. For polarization, what is the condition, beta? For polarization, reflected ray must be polarized. That means IP plus of your RP must be equal to 90 degrees. Now, if I'm taking it water and glass interface, beta. It water glass interface. So refractive index of water into sine of your I is equals to refractive index of glass into sine of your R. Now, using Brewister's law, you can say that tan IB will be equal to your N2 divided by N1. Okay. So tan I will be equal to Ng divided by N of water. That is 1.5 divided by that is 9 by 8. So I is equals to tan inverse of your 9 divided by 8. So this is approximately 48.4 degrees. Approximate value लेके करना है बेटा. Okay. So as it is a numerical, I can write this one as 48.4 degree. Okay, fine. Next one, wait. As shown in the figure, the resistance of galvanometer G can be found by an half deflection method. Here, the resistance R2 is adjusted such that when the key K is been closed, the deflection in the galvanometer becomes half the value as compared when K is open. Half deflection obtained at K2 is equal to 4 ohms. Thus, the galvanometer resistance is found to be 6 ohms. In half deflection condition, the current through the resistor will be equal to how much? For half deflection, you know that for your half deflection, resistance of your galvanometer will be equal to S into your R2 divided by S minus of your R2. Given in the problem right now for me, Rg will be equal to resistance of galvanometer is 6 ohms and R2 is equals to 4 ohms. So the circuit current division gives me what right now for me? Current through the galvanometer becomes half. So voltage across the parallel branch will be equal to V is equals to Ig into your Rg, isn't it? So current through I1 will be equal to how much better? It will become for me 3 amperes. Isn't it? So current through your R1 will be equal to 3 milliamperes. Current division rule I am using. Okay ना? Simple question था ये तो बहुत आसान question था. चलो next question देखो बेटा. In a system of units, the units of mass, length, time, and current are 5 kg, 5 meter, 5 second, 5 ampere respectively. If mu naught, epsilon naught are permittivity of free space, then in new system, the magnitude of SI is. Again, this is from units and dimension, from direct question better. Given quantity is right now for me, root of mu naught divided by epsilon naught. Dimensions of mu naught, you already know it. It is m l t power minus 2 I power of your minus 2. And epsilon naught is equals to, this will be equal to m power minus 1, L power minus 3, T power 4, I power 2. Okay. So under root of your mu naught divided by epsilon naught will be equal to, this will come out for me m into L square T power minus 3, I power minus 2. So now in the problem is telling that in new units, m dash is equals to how much for me? 5 kg. L dash will be equal to 5 meter. T dash is equals to 5 seconds. And I dash is equals to 5 amperes. So magnitude of the unit in new unit is asking. So we can directly do it out conditions, isn't it? So in new system, you can use the formula N1 U1 is equal to, but I can directly write from here itself. It will be 5 power 1. This is 5 power 2. This is 5 power minus 3. and this is 5 power minus 2. That will be equal to 5 power minus 2. That is approximately 1 by 25. So 1 SI unit will be equal to 25 units. So that will be equal to how much for 1 unit of SI equals 25 new units. So the answer must be equal to 25. Okay. Sure. This question again, paragraph questions are there, beta. Time consuming. Anyhow, let us try today. A container of height 2 meter, length 2 meter, breadth 1 meter is made insulating vertical wall and two large areas of horizontal metal plates M1 and M2 which extends far beyond the vertical walls in all directions. The container is partitioned into two equal chambers with a thin insulating vertical wall. The partition wall contains a small hole of cross-sectional area root 10 centimeters square near the edge. Okay, the hole is being closed and the left chamber of the container is completely filled with a liquid of a dielectric constant 15 and right chamber with 1. At time t is equal to 0, the hole is being opened and the liquid flows from the left chamber to right chamber. In both the chambers, the space above the liquid is 1 and is maintained to atmospheric pressure. The systematic container of the time t greater than 0 shown. Given acceleration due to gravity is 10. Okay, this is given. ER is 1 here, ER is 15. This is M1, M2, 1 meter. Okay. The height of the liquid in the left chamber, T is equals to 500 seconds is asked. So this is your dynamics question, but a fluid dynamics, the first question. Let us first try to calculate the area of each chamber. Area of each chamber will be 2 into 1. That will be equal to 2 meters square. Whole area will be equal to how much work? Area of the whole will be equal to under root of your 10 centimeters square. That is root 10 into, this is 10 power minus 4 meters square. CA is right now for me area of your hole, isn't it? So this is the area of chamber, area of your chamber. Okay. Let the left height be, say, for example, some h. Right chamber will be equal to how much at a time? 2 minus of your h, isn't it? So if I assume that, let left height at a time t be your h. So right chamber will become how much for me, beta? Right chamber height will be 2 minus of your h. So what is the difference right now for me? Difference will be delta h is equals to h minus 2 minus of your h. That is equals to 2h minus of. Now we can use your Torsilis theorem, beta. Because liquid has been flexing out. So using your Torsilis law. A into dH divided by your dt will be equal to minus of A into under root of your 2g into h is here 2h minus of your 2. Now integrating on both the sides. Integrating will be getting under root of your 2h minus of 2 is equals to 1 minus A into root 2g divided by A into your time t. Okay, now substitute the values better. So h value already I got the given conditions. This will be equal to A into your root of your 2g will be equal to root 10 into 10 power minus 4 into root of your 20. So that will be equal to 2 into 10 power minus 3. So I can write hence, your under root of your 2h minus 2 will be equal to 1 minus 10 power minus 3 into your t. So at t is equals to 500 seconds. How much I'll be getting this one, you see? Under root of your 2h minus 2 will be equal to, this will be 0.5. So it is 2h minus 2 will be equal to 0.25. So 2h will be equal to 0.25 plus of your 2. So it is h value will be equal to 1.125 meters. That means approximately I can write this one as 1.13 meters. That's numerical. Okay. So difference value will be equal to the height of the liquid will be equal to Clear, beta? Question number 16, देखो बेटा. The difference in the capacitance in farad between the metal plates at T is 0 and at T is equals to 500 seconds is 8 minus n epsilon naught, where epsilon naught is permittivity of free space. The value of n is how much? Okay. Question number 16, देखो बेटा. Uh, half dielectric constant is how much right now for me? Difference in the capacitance at T is equals to 500 seconds is 8 minus epsilon naught value. This is your electric constant is given for me 15. Right here is right now air. That means capacitance will be equal to C naught is equals to epsilon naught into A divided by D. Epsilon naught value will be equal to your into dielectric is also there, na? Okay, I need to apply the dielectric also right now. So it is into 15 plus 1 divided by 2. So this is coming out for me 8 times of your epsilon naught. Then at T is equals to 500 seconds. So left liquid height is approximately 1.125 height, isn't it? So right height will be equal to how much beta? Right height will be equal to 0.875 minus n beta. So effective capacitance will become how much at a time? C is equals to n times of your epsilon naught. So this will be C is equals to C value is 8 epsilon naught. I got it. So this would become for me 5 times of epsilon. So difference